So in this module, I'm going to talk about the architecture of the RPKI Workshop and what it's going to look like when it runs on your personal machine. It should be noted that this tutorial does expect you to have some knowledge about how the RPKI works. Although the demonstrations shown in the later modules do let you get a clue about what's going on, we don't dive into how the RPKI works and what happens underneath the hood. For that, you might want to find some other resources for learning about the RPKI. Or stay tuned, for we do hope to produce more videos in the future about how the RPKI itself works. But let's get back to how the RPKI Workshop is set up. It is expected that you'll run this on one of your own personal machines. We'll assume that your machine is connected to the internet. It actually does not have to be in order for this demo to work, but for purposes of completeness, we'll assume that it is. So this big box is what we're going to call your host machine. This is the host that the VM is going to run inside of. So the virtual machine will run on top of your host machine, and inside this virtual machine will run all our infrastructure. So when you load your RPKI image into the host machine as a virtual machine, you'll get everything inside of this box already set up. So our test infrastructure is going to consist of two primary routers that we assume are connected to the internet. They're not actually running BGP out to the internet or anything like that. This is entirely self-contained demo. But we do have two routers, which we'll call B0 and B1, and they both have autonomous system numbers of 65533 and 65534, as well as a management interface set up on an Ethernet interface of ETH0 and assigned an address of 10.0.3.10 and 10.0.3.13. These routers and the other infrastructure we're about to talk about are all implemented as separate machines inside the virtual machine using Linux containers. Linux containers are a way of emulating, in sort of a similar way as a virtual machine, a smaller machine inside of a larger one. Linux containers let us have a whole bunch of virtual machines with some Ethernet interfaces running BGP and all the networking support that we need for this demo. Connected to these two pretend peering routers, B0 and B1, that are supposedly connected out to the internet for routing purposes, is a bunch of what we're going to call student routers, or laboratory user routers. And they are numbered starting at R0 and have ASN 65001 and have a Ethernet address, which is one up from the other routers. These are the internal IP addresses for the control network. The actual address space, which is routed between all of the machines, is in the 192.168 block. And each of these virtual routers, of which there are 17 in total, numbered 0 through 16, they each have their own /24 subnet, as you can see in the has field under each router, starting with 192.168.0.0 and going up to 192.168.16.0/24. This workshop in a box is actually much more flexible, and later in the demonstrations we'll talk about how to assign new allocations and how to allocate new address blocks out to these routers as well. The other thing that we'll need is the ability to look at the RPKI.net web service, which is a GUI interface that makes managing RPKI and ROAs extremely easy, as well as a SSH daemon so that we can SSH into the box. The host machine gets there quite easily because it's connected to the same address space, but if you have other users in your neighboring network that want to join the fun and play on the routers, they'll need port forwarding enabled in order to get into the RPKI.net web server and the SSH daemon. And in the setup video, I'll show you how to go about doing that. This RPKI testbed infrastructure is a great place to experiment with the RPKI and do it in a safe way, where you can learn about and test the technology before you deploy it in your real infrastructure. Our tutorials will walk through this whole architecture and show you in pieces what each component does, as well as how to manipulate the data within each of these components. In our workshop demonstration, we've set up a fake IANA route that has the entire IPv4 address space, in other words 0.0.0.0/0, the entire space. From there, we set up a allocation to a holder called the workshop. It has 192.168.0.0/16 allocated to it. So it has an entire /16 prefix allocated to the workshop space. Because this is a dummy environment, you are welcome to go in and play with adding new allocations from IANA to the workshop. But to continue on with the default setup, the workshop has allocated out the 192.168.0.0/24 address space to the R0 router and to the user lab user 00, which is what you can use to log into the virtual router inside of the virtual machine. We'll cover that in detail later. And as I mentioned before, there's actually 17 total virtual routers from R0 to R16, and they all have various address blocks allocated to them from the workshop address holder. Finally, here's a short list of some of the things that you can do with the RPKI Workshop setup. You can learn how to play with a number of things in the RPKI.net UI. You can create and delete ROAs, you can create Ghostbuster records and allocate new resources. And in the routers, you can learn how to use Quagga, which is the routing interface given to the students, and learn how the RPKI changes route validation status. All of these will be demonstrated and shown in later modules, so you can watch the videos and learn from them as well. In the next module, we'll walk you through setting up the RPKI Workshop so that you can try things yourself.